Okay, I just started the recording. We're working on this problem where here's an inequality because it's got a less than in it. And I ask you to solve it, but then graph its solution on a number line and write that answer in interval notation. So I'm going to go through this. Keep in mind, last night I did some warm-ups. Tonight I'm also doing some warm-ups. Okay, this one in particular. We have a quiz this Thursday night around 8 o'clock. Like I told you last night, it'll have 15 questions. You'll have 90 minutes. Okay, once you start, but it must be done by midnight. So if you start right at 8 o'clock and you get done, like last week, you had like 70 minutes to do 29 questions, and people were coming back into Zoom after 5 minutes going, I'm done. Was it that easy? I'm going, huh? Okay. So some of you guys are smarter than I thought. The other thing I need to make sure people know is that upload assignment. Remember, there's 3 pages. Okay, you handwrite a note, draw a little picture, and copy something from a text all as one file. That's due, I believe it's due this Sunday. Okay, and there's still about 10 people in the class who haven't done it. Okay, so make sure you get that done. If you're not doing that, you're kissing away free points. Okay, that's free points. It's an easy assignment. If you don't get it done, you're just throwing away points, and I don't know why, but you are.
I think it's due Friday.
Is it Friday? Okay,
Yeah, Friday by midnight.
Also, okay, so the upload, thank you. I don't want to give bad information. Due Friday at 11:59 p.m. I'll leave that up. Okay, so here we go. Back to here. First step, distribute. So we have 10 minus 6x less than or equal to 4x minus 5. Okay. There's no fractions, there's no decimals. Okay. So we want to get our x's on one side, our numbers on the other. Now, there's been some discussion for inequalities. It's safer, not required, but safer to have all your x's on the left-hand side. It's not required, it's just simply safer. So I'm going to take away 4x from both sides. That's going to give me 10 minus 10x is less than or equal to negative 5. Now I've got all my x's on the left, so I want to move all my numbers to the right. So I'm going to minus 10 from both sides. That's going to give me negative 10x less than or equal to negative 15. Okay. I want to get x alone, so I'm going to divide both sides by negative 10. Now, some stuff here. This gives me x because the negative 10s cancel. This reduces to positive 3/2 or 1.5, your choice. I don't care, but you do have to reduce it, guys. The negative divided by negative reduces to a positive, and 15/10 reduces to 3/2. If you want to call that 1.5 or 1.5, that doesn't matter, but you do have to reduce it down. Question to everyone. What about that inequality? Do I flip it?
Yes.
Yeah. When you divide both sides or multiply both sides by a negative number, it flips the inequality. So this flips over to be greater than or equal to. Okay. So this is what's called set notation. Okay. If we graph it, here's 0, here's 3/2, 1.5. Okay. Because it's equal, we put a solid dot, and then it's pointing in the direction we shade. So it looks something like that. X is greater than 3/2. That would be its graph. Okay. Mitch, I think you like the bracket on there instead of the dot. That's fine. Okay. Also then now interval notation, it would be bracket, 3/2, comma, infinity, parenthesis. Okay. So yeah, there's going to be inequalities like this on Thursday's quiz, tomorrow night's quiz. Is that okay with everybody? This was set notation. This was interval notation. Is that all right with everybody?
Yes.
Yes.
Okay. Now, I promised a long time ago and then forgot. I need to erase this part of the problem for a second. Can I do that? Nobody's going to scream at me? Okay.
1 second, please.
Yeah.
Oh,
Okay. All right. What was this? This is 0. Here's 3/2, comma, infinity. I was going to try to explain to you why we flip this. Okay. Why do we flip it? What math says we got to flip this? Can I erase now?
yes.
Okay. Okay. So, okay. Math, believe it or not, is a philosophy. Math says if you start with something that's true, whatever you do to it, you can't change it from a true statement to a false statement. Okay, that's why we have things like if you start with I don't know, 2 is less than 4. Well, that's a true statement. Okay. And let's say you add 5 to both sides. Then we get 7 is less than 9. Well, that's also a true statement. By the way, you do not need to take notes on this. This will not be tested in any way. This is just kind of for your understanding. Okay. So from that, we generalize and say, oh, look, if I have a true statement, an inequality with something that's true, and I add something to both sides, add the same thing to both sides, I maintain truth. I keep it true. So we say, okay, it's okay to add the same thing to both sides. But wait, what if I subtract 5 from both sides? What if I take away 5? I start with something that's true. 2 is smaller than 4. If I take away 5, I get -3. I get -1. Is -3 smaller than -1? Think about that. On the number line, anything to the left, the more to the left you go, the smaller you are on a number line. So the more to the left I am, the smaller I am. So yeah, -3 is smaller than -1. So this is still true. And so from these examples and more, we run into a rule that says, oh, if you start with a true inequality and you take away the same thing from both sides, your equality will still be true. Okay, remember, the bottom line here, math says if you start with truth, you must always end with truth. And all of our rules that we give you, okay, are to kind of keep the truth. All right, so what happens if we come back here and we multiply both sides by 3? Okay, so we get 6, 2 through 6, we get 12. Is 6 less than 12? Yeah, it's true. Now I'm going to speed this up now. Okay, so we go through all these examples, and this says, okay, if you multiply by a positive number to both sides, you still keep the truth. But what happens if you multiply both sides by a negative number? Okay, well, you get negative 10, you get negative 20. Is negative 10 less than negative 20? Look at them on the number line. Here's 0, here's negative 10, here's negative 20. Is negative 10 smaller than negative 20? No. So that gives rise to, okay, we did the same thing to both sides. We multiplied both sides by a negative number, and yet it gave us a false answer. Okay, and now we can go back and double and triple check that. We started with something true, we multiplied both sides by a negative number, and we got a false answer. Therefore, in order to maintain truth, okay, we invented a rule that says, okay, if we want truth, we have to flip this over so we now have truth. Okay, everything is intended to be truth. What we've then told you guys as students is shut up and memorize this rule. If you multiply both sides by a negative, you have to flip the symbol. The reason has to do with the philosophy in math of maintaining truth. Okay, and I can go through another example with division, but pretty much that's it. We want to always maintain truth. So all the rules we give you, all these stupid, well, I'll just call them rules for now, you know, the techniques and everything like that are always meant to keep the truth. Okay, so there's a nice philosophy lesson. All right, another warm-up that I want you to do. Now, this does not have anything to do with tomorrow night's quiz, but this is kind of last night's lesson, a little bit. Okay, I want you to find the equation of the line, parentheses, in slope-intercept form. Okay. Number one, that passes through. Okay, what points did I have here? 2, -3, and boom, 7, 1. Okay, and number 2, I'm going to give you a graph. Okay, here's a graph. This is the x-axis. This is the y-axis. Okay, and this point up here is 0, 44. And this point down here is 132, 0. So I'm going to pause the recording in just a second. You're doing 2 problems. You should be looking at last night's notes. This was in last night's notes. This is an extension. This is kind of tricky right now, but I'm going to go over both of them. All right. Last night when I taught this, I said to find the equation of a line, you need 3 things. You need a point, a slope, and a formula. Well, we've got 2 points here, but what we're missing is the slope. Okay, but from a previous lesson, we learned that the slope was this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That formula will find the slope given 2 points. So we say m equals 1 minus a -3 over 7 minus 2. So the slope is 4 over 5. I think that's right. Okay, but we're not done because this didn't say find the slope. It said find the equation of the line. And I can't stress this enough, guys. When you're doing your problems, ask yourself, have I answered what the question was? So many students go, wow, I found the slope. Cool. Yeah, well, that's not what the problem wanted. Finding the slope is a midway step. Okay, it wants the equation of the line. So then, again, we did this last night. So we take the slope and we plug everybody into this formula, everything we can into the slope intercept formula, y equals mx plus b. Okay, so I have 2 points. You take your pick, whichever one you want. I would choose this one because it's got positive numbers. Okay, and I know that I screw up with negatives, but we should always get the same answer regardless of which point you use. That doesn't matter. Okay, so I'm going to use this one and say 1 because that's the y value equals 4/5 times 7. So I'm plugging this point and this slope into this formula plus b. Okay, the rest of this is done on your calculator. So 1 equals, this turns out to be 28/5 plus b. To solve that, we're going to take 28/5 away from both sides.
You got the 28/5 by multiplying the 4/5 by 7, correct?
Right, because when you have 4/5 times 7, the rule is you have 4/5. Remember, you can always cheat a 1 under the number. And then to multiply fractions, you multiply straight across.
Okay.
4 times 7. Are you okay?
Yeah, that's perfect. Thank you.
Okay. So take away 28/5 from both sides. And I believe I get negative 23/5 equals b. Okay. Can anybody confirm that? Because last night was
Yes.
okay. Yeah, remember last night was a bad night for me. I was making all kinds of dumb mistakes. Which reminds me, Lindsay, are you okay?
I am. They didn't get their shipment of vaccines in time, so they rescheduled my appointment for next Tuesday.
Okay.
So ask me again next week.
All right, will do. Where'd my daughter go? You guys know where Municipal Gym is in Balboa Park? You guys know where Muni Gym is in Balboa Park by the Aerospace Museum or behind the Oregon Pavilion? She bopped in there at 2:30 this afternoon and said, well, I take care of my grandmother once in a while. And they said, oh, okay. And they gave her a shot. Number one, a Pfizer shot, her first one. So you guys, if anybody's looking for that, it was at the Muni Gym. I don't know if they're still going to be open tomorrow. I have no idea how she found out about it. But the Municipal Gym in Balboa Park, right behind the Oregon Pavilion, she got a Pfizer vaccine today, and she just walked up and said something about every once in a while I take food to my grandmother, or I take her shopping. And they said, oh, you're helping an old person. She goes, yep. So guys, for what it's worth, take advantage of it. All right.
Professor, we're not getting 23/5.
Yeah. How did I?
Yeah, because I'm doing 1 divided by negative 28/5.
Oh, no. Time out. It's subtraction. This is 28/5. To get rid of it, we subtract 28/5 from this side. We subtract 28/5 from this side. That's a subtraction problem, not a division.
Dummy, myself. I got it.
Got it? Okay. Now we put all this junk together. Okay. Okay. We put all this junk together, and our final answer is, if I put it down here, y equals, we figured out the slope, which was 4/5 x, and then the b value is 23/5. And this is the equation in slope intercept form that will guaranteed go through those 2 points. And that I guarantee is going to be on the chapter 4 quiz when we get there eventually. That's in like a week or two. I guarantee I will have problems like that on exam number 1. I guarantee that. So put a star on this problem. It's going to show up a lot, okay, in the chapter 4 quizzes, chapter 4 homework, and the exam number 1, okay, that we're going to have whenever that is, March something or other, I don't know. Okay, and that's right from last night's work. I did a problem similar to that last night. This is, again, another one. So, okay, wait a minute, time out. I'm not picking on you, but who was saying they thought that was a division problem?
Me, Richard.
Okay, Richard, I'm picking on you only because you made the comment. Okay, look, everybody makes mistakes. The fact that we were able to catch your mistake, you, Richard, should in your notes write something like not division. Okay, because that's personal to you. Now, somebody else might have made another mistake up here, like, oop, got the formula wrong or something. Make notes to yourself. Don't just copy my problems and say, okay, that's it. Okay. Okay. Where did you screw up? Where was an aha moment? I understand it now, right there, or how he did that. So this is the work, but make it your own by putting personalized notes in.
Do appreciate it. Thank you.
Yeah. All right. So I kind of sort of need to maybe erase this problem number 1. Are we okay? Okay, I don't hear anybody yelling. All right. Okay. If I erase, you're gonna yell at me again?
No, no.
Okay, okay. All right.
That's
Now,
not what I meant.
this particular problem, I still want the equation, okay? But looking at this, there's some tricks here in this problem where we can really shortcut our work. Now, if you wanted to, you could do this problem just like we did this problem. What was this? 7, -3. Yeah, sorry. I erased it. You shouldn't have.
1.
Oh, 1. Thank you. Okay. You can say, oh, okay, I have 2 points, so I can find the slope. Okay, and then I can plug everybody in and finally get the equation. You can do that and you'll get the problem 100% correct. There's nothing wrong. But where there's shortcuts, let's try and take them. First thing, when we write y equals mx plus b, okay, what did the b stand for?
Or y-intercept.
The y-intercept. This was the y-intercept. Well, guess what? In this particular problem, this is the y-intercept. It was just there. Okay, they showed it to me on the graph. So this is my b value. I don't have to do any work for it. You guys see that? By knowing the pieces of the formula, the b stood for the y-intercept. Okay, so I can just look up there and go, duh, that's the y-intercept. B is 44. Yay, I'm done. Now, M stands for what? Anybody?
Slope.
The slope. Okay. Now, there's a bunch of ways that we can think of the slope. We have this formula, y sub 2 minus y sub 1, x sub 2 minus x sub 1, blah, 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 blah. But we've also thought of slope as rise over run. So if I look at this problem here and say, how did I go from this point to this point? Well, I go down 44, but I go sideways 132. To go from this point to this point, I had to go down 44 and then sideways 132. Well, put that in the rise over run. The rise was negative 44. The run was 132. Okay, now I think that reduces to negative 1/3. Somebody pop that in your calculator, does it? I'm pretty sure it
Yeah.
does. Okay,
How'd you get negative 44?
well, because it was going down. Okay, I started at 44 and it came down here. So 44 down to this
Like
point,
the line is going down pretty much.
pardon me, say again?
Like the line is going down. Is that how you
Yeah,
know?
yeah, yeah. That's how you know.
Thank
So I went down 44, but I went sideways 132. So looking at that, plugging it into the concept of rise over run, I have my slope. Well, look at this. My equation now is y equals negative 1/3 x plus 44. That's my answer. And I did very little algebra. Very little algebra for that problem. I had to understand my algebra. Okay, but I didn't have to do much. I knew I was looking for a slope and a y-intercept. I look at the problem and go, that is the y-intercept. So I don't have to do that work. Had to find the slope. Well, how do I find the slope? Rise, going down means negative. Run, positive, 132. So I put rise over run. I reduced it. Now I have my slope. So I plug everybody into the formula and I'm done. Okay, I want to repeat that you could have done this problem exactly like we did this problem. And you should have gotten exactly the same answer that we got over here. Okay, I'm just offering in certain circumstances, especially when they give you the graph, when they give you a picture. Okay, there are some shortcuts available to you if you know what to look for, where to find them. Okay, I want to move on. How are we doing? Any questions about either of those problems? No, okay. So believe it or not, we have one more topic in chapter 4, and then we move on to chapter 5 tonight. We just be flying through this stuff, okay? So this was a good problem. Make sure you star it, have it in front of you when you do your homework. Make sure you know what you're doing when the test comes, okay? This problem. This is a possible shortcut problem. Save yourself a lot of time and a lot of work if you can do it. Okay, okay. So we're doing chapter 4.7 tonight. And we're going to graph linear inequalities. Okay. I'm going to start by doing a problem, and then we'll do a couple of them together for the night. So here's the problem. I want to graph y is less than 2x minus 3. I want to graph that. Well, the first thing we're going to do is what we learned last night. We're going to pretend that this is y equals 2x minus 3. Okay, and what we learned last night to graph this is that our point, okay, our y-intercept is 0, -3. We can just look at it and see, and our slope is 2/1, which is also rise over run. Now that's kind of important, so I'll make sure
Okay.
everybody is
I was
caught
actually
up.
gonna
Okay.
ask you this. So if the slope is ever just one whole number, you're just gonna put a 1 underneath of it every time?
Yeah, because you have to have rise over run. It's a fraction, it represented, so you always cheat a 1 under there. Yes.
So that slope would be 2 over and 1 up?
No, 2 up
Or 2
and 1
two
over.
up and 1
yes.
over? Okay, yeah.
Yeah. Okay, so is everybody okay with how I got the y-intercept of 0, -3? Just by looking at it. And how I got the slope was 2/1 just by looking at it. Because that's what you're going to have to do. Okay, then to graph this like we did last night, okay, we start at 0, -3. That's the first thing we do, 0, -3. And then we use the rise over run. Okay, so we rise 2, run 1. Okay, now mom is going to require you, if she says use slope intercept, you have to know what that point is. So if you rise 2 and run 1, this should be 1, -1. When I rise 2, -3, up 2 is -1, 0, run 1 is 1. Okay. Now, those of you who have been ignoring me saying, I know how to do this, I know how to do this, I need your attention. Okay. This is a line, but it's not a line. Think about that. We draw this as a dashed line. A dashed line, dotted line.
Why is that?
Okay, because in the original problem, okay, it said y is less than the line, but not equal to it. If this had been less than or equal to, then we would draw a solid line. Okay, since it's less than, it's a dashed line. If it was less than or equal, it would have been a solid line. That's the first thing. Okay. The next thing is because it's an inequality, we have to shade. Okay. So you've only done half the problem now. You've graphed the line and you've made it dotted because of the less than. Okay. Even if it was greater than, it would still be dotted. It has to have an equal sign under there to be a solid line. Okay, but we'll come back. We'll do more of those. So I've got a shade, huh? I have a choice. Do I shade below or do I shade above? That's my choices, below or above. Now I'm going to show you two methods. I'm going to show you the technically correct method, and then I'm going to show you the shortcut method. Okay, so before I get into shading, is everybody okay with how I graph this line? I got this. Where did I get the point 1, -1? Where did I get that one from? And are you kind of okay with it being dotted?
Yes.
Okay, here we go.
I
Now,
have about
okay, go ahead. Go ahead. What?
about zero
Sure.
zero. How you find zero?
Okay, Google, shut up. Okay. How did I find? Oh, the B value, the 0, -3, it's always that. The y-intercept is always 0, something.
Oh, okay.
It's always 0, something. If for example, you'd had, let's say you were doing y equals, y is less than 7x plus 5, then it's going to be 0, 5. Always the 5 is the y-intercept, so it's 0, that number.
Okay.
Okay?
Yeah.
All right.
So how did you get the 1, -1 again,
Okay.
please?
Because I used rise over run. I said I went up 2 over 1 from here. So
Oh, okay.
going over 1, if I'm at 0 and I go over 1, I'm at 1. Going sideways changes the x values. If I'm at -3 and I go up 2, -3 plus 2 is -1. So this was my rise and run. Okay, and I just added them to that point right there. Is that kind of okay or not okay?
Okay.
Okay, that didn't sound very convincing. All right, but let's go forward. We'll do another problem. We'll get there. Okay. Shade. The traditionally correct way to shade is to pick what's called a test point and plug it in. Okay, plug it in. Now, what test point do I pick? Keep in mind, you're going to be the future mathematicians and you're lazy. You want to pick any point in the whole plane that's not on this line. It doesn't matter. You can pick a point here, 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 here. Any point you want, as long as it's not on the actual line itself. Okay? Most of the time, we'll pick 0, 0 for our test point because we're lazy, because math with zeros is easy. There's our test point. Okay, so we're going to plug it into the original problem. Our original problem was y is less than 2x minus 3. Plug it in. 0 is less than 2 times 0 minus 3. Do your arithmetic. 0 is less than -3. Is that true or false? Is 0 less than -3? No,
False.
that's false. Okay. Remember my little discussion a few minutes ago? Math is really big on truth. Okay. Superman, truth, justice, the American way. Anybody ever watch Superman on TV? Back in the 1950s, if you watch the early Superman, I'm not talking about the animation one. I'm talking about the guy wearing the funny shorts, stuff like that.
It's early.
Okay, George Reeves, I think is a whatever. Okay, they used to say truth, justice, and the American way, and then after 2 years, they changed it to truth, justice, and the pursuit of happiness, because somebody figured out the American way not necessarily was the happiest way. Okay, and they wanted to appeal to the worldwide audience, so they changed him a little bit. But Anyway, back here, enough sociology. Our test point was false.
Yes.
Okay, that means everything above the line is false. That test point represented all of these. If above is false, where's truth?
Below.
Below. Exactly. And so you would shade below, and you're done. So, okay, when you see an inequality, you know you have to shade. You're either going to shade above the line or below the line. And you've got to figure out which one. The traditional way is to pick a random point that's not on the line, but we always try to pick 0, 0 because it's easy. Plug it in and answer true or false. This was false. That meant the test point was above. Everything above is false. So the only truth must have been below. And that's your answer, and you're done. Okay. So now I'm going to show you the shortcut in a second. Okay. Is that kind of okay with everybody? We'll do a couple of these and then you guys can.
Yeah, I was gonna say I'll need it a few more times to get it.
Yeah, we'll do it a couple times, but let me show you the shortcut now. But the shortcut is based upon an if, a big, giant if. If your equation is in slope-intercept form. If, really important. If it's not, you can't use the shortcut. But if it's in slope-intercept form, then less than means below, greater than means above. Just think about it. Less than, below, greater than, above. So look at this original problem. It's in slope-intercept form, y equals mx plus b. It says less than, we should have shaded below. Okay, and we did. And it's as easy as that. But it's very important. It's got to be in y equals mx plus b format. If it's not, you can't use that shortcut. Okay.
What,
right.
what would be an example of it not being in Y format?
I'm going to do that right now. Good question. Okay. And I'm going to walk you through it also. Okay. This one. And then we'll open it up to let you guys try a few more. So you guys got this problem copied? Yes. Apparently. Okay. Here we go. So what if I said, here, I want you to graph this one. 2x minus 5y is less than or equal to 10. Okay, well, this is not in slope-intercept form, so we cannot use the shortcut trick. Okay, now if you want to manipulate it into slope-intercept, you go right ahead, that's okay. But I want to remind you, one of the things we learned is we learned how to use intercepts. Okay. Remember, that was one of the things that we learned how to graph a line, plug in some points. So if x is 0, we have 2 times 0 minus 5y. We're going to pretend that it's equal to 10 for now. We're going to pretend it is, okay, because we don't care. So this is negative 5y equals 10. This tells me y is negative 2. Remember, we did this. This is one of the first ways we graphed a line, is we plugged in 0 for x, plugged it in, got y is negative 2. Then we turned around and plugged in 0 for y. So this is 2x minus 5 times 0 equals, wait a minute, I'm sorry, I screwed up. This is a positive 10. I don't know why I wrote negative there. The answer is still -2. I screwed up twice. Equals 10. Divide, so this is 2x equals 10. X is 5. So on this one, I have 0, -2. Okay. I get out of the way in a minute, and I have 5, 0. Okay. So this one it's called standard form. It's just not slope intercept. It's called standard. And it seems easier to me to build a table of values. Okay, so I did. And I got my intercepts here. And that was part of your mom homework. Some of the assignments said graph using the intercepts. So you had to find these 2 points and then draw a line that connected them. Okay, question, will this line be a solid line or a dotted line?
Solid.
Solid, because of the equal sign. So it's going to be a solid line. Okay. Now, I've graphed it. I've done everything. I still have to shade. I still have to shade. I can't use the shortcut because this equation is not in slope intercept form. It doesn't look like y equals mx plus b. So this time I have to use the test point. Have to. Okay. And before you go, okay, I'm never going to use the test point because I know a way around it. We're going to get some problems later this semester where the test point is the only way to do the problem. So don't just ignore this. It's going to come back and bite us and become necessary. Try and learn it now so that when we have to use it in the future, it will be easier for us. But anyway, we're going to pick a test point. I'm going to pick, I'm going to say I want to test 0, 0. And remember, the only condition that I want is that my test point can't be on the line. Hey, if I wanted to pick 5, -5 out here, you could have picked it and used it. If I want to pick 0, 15, I can use it. Any point is a legitimate test point. But keep in mind that you're lazy. You want to do the least amount of work necessary. So 0, 0 is the easiest to use. Okay. So here we go. I'm going to plug in 0, 0 to the original problem. I have 2 times 0 minus 5 times 0. Plug it in is less than or equal to 10. So that's 0 is less than or equal to 10. Because 2 times 0 is 0. Take away 0 is still 0. Is that a true or false statement? Is 0 smaller than 10?
True.
True.
Oh.
What? Okay. I have 4 trues and 1 false. What?
It says less than or equal to, though, right?
Oh, yeah, but it's either one. Less than, true, forget the equal. Okay. 0 is less than 10. Don't worry about the equal. We covered the equal with the solid line. Okay. It is true. I understand the confusion about the equal sign. It doesn't have any bearing in this test. So let me see this. My test point was true. The test point was above the line. That means truth must be above the line. And so that's where I shade, just up like that. And you're done. That's it. Okay, so the question was, and I think it was Richard, I didn't see, when are we going to get problems that aren't in slope intercept form? There. So this is now Foster speaking personally. I kind of subscribe to the jujitsu of graphing. If my equation looks like this, it's easier to build a table. I kind of go with what the problem gives me. Whatever it gives me, I kind of take it and go with it. If the problem looks like this, I build a table. If the problem looks like this, okay, slope intercept, I use rise over run. So I use both methods, okay, when I'm graphing lines, because when it looks like this, I can use the rise over run and be done quickly. When it looks like this, I can use my intercepts and be done quickly. So depending on what the problem gives me, I use a different method to graph each one. Okay. You would be well served if you could do the same thing. If you could be flexible enough to say, oh, this kind of problem is begging me to use a table. This kind of problem is begging me to use rise over run. All right, we'll do some more. Questions on this problem? Okay, so okay, I want you to graph this problem. Y less than or equal to negative 2/3 x plus 2. So we'll pause it. I'll let you guys work on it for just a second, and then we'll come back and work it as a class. Okay, while we were working, I had the recording turned off. The question was, a question was asked, what was this called? Anything that looks like this format, y equals mx plus b, okay? Anything that looks like that is called slope intercept form, slope intercept. And I personally would use the b value and then the slope as rise over run to help me graph it. And that's how I'm going to do this particular problem. But that's the name of this type of equation. So from this, okay, we get the y-intercept, which is also called the b value, is 0,2. That's the y-intercept or the b value, 0,2. And it's always 0, that number, okay? The slope is the m, is negative 2/3, which we think of as rise over run.
That says y minus mt.
No, that says y hyphen int. My bad handwriting. Y hyphen int. Short
Okay.
for y-intercept. That was just my bad handwriting on that one. So again, looking at this equation, I recognize it's in slope intercept form, so I can pull this information out just like that, instantly. Okay. Do I have room down? Yes, I do. Okay. So my y-intercept is 0,2, which is right there, 0,2. Little bit tricky. I'm going to go down 2. I'm going to rise -2, down 2, run 3. So I'm going to go down 2, 1, 2, run 3, 1, 2, 3. Turns out that that happens to be 3,0. Just happens to be that. Nice problem. All right, question. Do I connect the dots with a solid line or a dotted line?
Solid,
Because
because it's equal to.
Okay, you guys all agree? Okay, that,
Yeah.
I would agree that that's correct. So solid line goes something like that. Yeah. Now, because it's a less than, greater than, because it's an inequality, I have to shade. Can I use the shortcut on this particular problem?
Yes.
Yes. So I'm looking at less than. Less than means below this line. So I would shade like this and be done because I use the shortcut. That's it.
Can you do that one more time, the shortcut thing?
Yeah. If it's in slope intercept form, which this was, we talked about that earlier, then less than means below the line. Okay. If it had been y is greater than, I don't know, 5x plus 7, okay, it would look like that. But because it said greater than, that would say shade above the line. Greater means above.
And we don't need like a test point to figure
Nope.
that out?
No, that's why it was called the shortcut. You can avoid the test point just by saying, if it's in slope intercept form, then I could just use the less than or the greater than to tell me where to shade. If it's not in slope intercept form, then I have to use the test point, which is what we're going to do right now. Okay. Is that all right with everybody? You're going to get tons of practice on this in your mom homework and when we hit chapter 5, which is in about 10 minutes from now. Okay, so I want you guys to try this one. Negative 3x minus y less than negative 9. So I want you to try and graph that. Personally, I would build a table and plug in 0 for x and then 0 for y. That's my personal choice, but that's up to you. So we'll pause and let you work. Okay, so I would pretend that this was negative 3x minus y equals negative 9, and I would build an xy table. And now I'm going to start to shortcut it. If x is 0, then this part of the problem will be worth 0. So I have negative y equals negative 9. If x is 0, this part of the equation is 0. So we can cover it up. And I have negative y equals negative 9, which means y equals positive 9. You're doing the plug-in in your mind instead of on paper. If
What
X
about
is-
the equal sign instead of the
These-
less than sign?
Hang on, these are just to get you the ordered pairs. We'll worry about the less than when we do the shading and the dotted line. This is just to get us the ordered pairs, 0, 9. Okay. If y is 0, so we plug it in. This part of the problem goes away and we get negative 3x equals negative 9, which means x is 3. So we pretend for just a second that it's an equal sign. We mentally plug in 0 for x and do as much mental arithmetic as we can to solve for y. Y is 9. Then we plug in 0 for y, do as much mental arithmetic as we can, and get x is 3. Now, those are just the points, the intercepts. Here's 0, 9, wherever this is. 0, 9, and this is 3, 0. That gives us our graph. Now, first thing we want to do is,
I'm just confused about that graph thing. I'm sorry.
what thing?
The table, I don't know why it's not making sense to me. Like, I don't know what to do once I plug in the X or the Y
Okay,
with the problem.
you're doing what we did before, what we did a couple days ago. Okay, you're saying, you're doing this, you're saying if X is 0, then we plug it in. So you're going -3 times 0 minus Y equals -9. You're solving that equation.
Right, but how do you do that?
What's -3 times 0?
0.
So this becomes -Y equals -9. But I want to get Y, so I divide by -1. So this gives me Y equals +9. You're just doing all that equation solving.
You know,
Okay. Then doing the same thing, if Y was worth 0, okay, you're plugging it into this equation. So you have -3x minus 0 equals -9. But the 0 drops out, so I have -3x equals -9. Divide by -3. Okay, and I get Y, x is +3, because -9 divided by -3 is +3.
so I got -3x equals -9.
Right?
Oh, right, and then you divide. Okay.
Yeah. So all of this, see, notice the equation solving here goes back to what we were picking up in chapter 1 and chapter 2, I should say. So this type of equation solving after we plug in the number is chapter 2 stuff. So that's what's so hard about math, is it keeps building on previous skills. And if we didn't get those previous skills solid, then it's screwing us up in the future. But anyway, we get this. So I'm going to take this table and transfer it over here to make room. 0, 9, 3, 0. So I'm going to erase this table to make room. But the results of the table were when X is 0, Y was 9. That's what that says. And when Y is 0, X is 3. That's what that says. So I want to erase this table. Is that okay with erasing the table for everybody? Do you understand where those ordered pairs came from?
Yeah.
Everybody, though.
Yes.
Yes.
Okay. Yes. Okay. So now, those give us points, ordered pairs. So the first one is 0, 9. 0, 9 is there. 3, 0 is there. You guys told me a second ago that it's a dotted or dashed line because it was a less than, not an equal, a less than. So that makes it a dotted line. This is less than an equal, so it was a solid line. That's the difference. Okay. Now, the only problem is where do I shade? Above, below. Okay, do I shade down here, this way, to the left and down, or do I shade this way, right and up? And the easiest way is to pick the test point. So I'm going to test this point right here. That's my test point, 0, 0. So I plug in 0, 0. So I have -3 times 0 minus 0 less than -9. So I'm plugging all this in. So this becomes 0 minus 0. So this is 0 is less than -9. Is that a true or false statement?
False.
False. Okay. That means my test point was false. That means everything below the line where the test point was is false. So that implies truth must be up here, and that's where I shade. If this was false, then above it must be true, and we always shade towards the truth.
I thought if it was less than, you would shade below.
Only if it's in slope intercept form.
Ah, okay, I gotcha.
Okay, only if it's in slope intercept form. Now, I know some of you would maneuver this, use your algebra skills to get y alone. And assuming you don't screw up, that's a legitimate way to do it also. I don't want to do it, okay? But if you know what I'm talking about, that's legitimate. Okay, that's why I wrote the big if. If it's in slope intercept form, then you can use the shortcut method. But if it's not, then you got to use the test point. Okay. So we're going to move on now. What time is it? 8 o'clock, almost 8. So we got enough time to start chapter 5. So draw a heavy line in your notes and indicate chapter 5. Here we go. Chapter 5 is all about something called systems of equations. A system is two or more equations. So, for example, okay, we write this. The brace here is just meant to indicate that these two separate equations are actually part of one big problem. This is a system of equations. It's two equations with two unknowns. This is called 2 by 2. We write 2x2, but we say this is a 2 by 2 system. That means it's got two equations and two unknowns, two variables. This is a 2 by 2. Okay. This one, another example. Okay, I'll read it to you. First line says A plus B plus C equals 2. A minus B plus 2C equals 6. That's the second one. Third equation is 2A plus 3B minus C equals -1. Now, this is called a 3 by 3 system. 3 by 3 system. And it gets bigger. We are going to stick with 2 by 2s and 3 by 3s. Anything more than that, that's when you go out and you buy a $120 calculator. Or you look online for something called a system solver. But these are called systems of equations. These are called 2 by 2s, 3 by 3s. There's 4 by 4s, 5 by 5s, 10 by 10s. When they're trying to do some of the math for quantum physics, they're up to 20 by 20s. 20 equations with 20 unknowns. It's just insane. Okay. And to even try and explain to you what the hell they mean is confusing. All right, but you'll notice also that we can use X's and Y's, or we can use A, B's, and C's, anything we want. They're just variables. It doesn't matter whether you say X, Y, A, B, C. They're just variables. Now, a key concept. A solution is an ordered spelling, O-R-D-E-R-E-D, pair, okay, that makes all, really important, all equations true. A solution is some ordered pair that makes all equations true. So first one is 2 comma negative 1 a solution to the 2 by 2 system. So looking over here, here's the 2 by 2 system. Okay, and I've given you the ordered pair 2 comma negative 1. Is it a solution?
No,
How do you know?
it doesn't work with negative 17.
Okay, good. It works in the top one. It's okay in the top one. Okay, that's why I picked this problem. So if you plug it in, you have 2 times 2 minus negative 1, whoops, equals 5. You do a little bit of math and you get 5 equals 5. So you go, yep, check. It works in the top one. But if you try and put it in the bottom one, you get 2 plus negative 1 equals negative 17. And you go, no way. So this would be considered not a solution. So the first thing that mom is going to do when you do your homework in chapter 5, when you start 5.1, is she'll give you some equations, some system of equations, and ask, is this a solution? And so mentally, scratch paper, I don't care how you do it, okay? You plug these into the equations one at a time, and it has to make both of them true at the same time. Both of them. She might give you an ordered triple, an ABC. She might say, is 3, 7, negative 1, 3, 7, negative 1 a solution to this 3 by 3? And you'd say, have to say, well, if this is 3, A is 3, B is 7, C is negative 1. If I plug it in here, does it make it true? So you just plug it in. It's just a crummy way of getting you guys to do arithmetic. Okay. Good question to start. I sincerely doubt that I will ask that on a quiz. It is on the homework. Okay. But I don't think I'll ask it on the quiz. It's just silly. Okay. Good to know. That's it. So anyway, this is an introduction to what is a system. A system is 2 or more equations. Okay. This is called a 2 by 2 system. This is called a 3 by 3. There's 4 by 4s and 5 by 5s, and we won't even touch them. We won't come close. But the key idea here, besides the idea of a system, is what is a solution? A solution is something that you plug in that makes all of the equations true. Not just one of them, all of them. Okay, now, moving on. That's what a system is. For us, okay, there are 3 possible outcomes. Three possible outcomes. Now, and I'm going to show this to you graphically. Where's my money? I get so many pens. Okay. Which is what your first homework in chapter 5 is going to be. If you graph two lines, okay, let's say you have equation number 1 and that's its line. Remember, a system is two equations. So let's say that's the line number 1 and it looks like that. And let's say the other line looks like this. This is equation number 2. Okay. So let's pause for just a second. Remember up here, I had an example of a 2x2 system. And you could have graphed those. Let's pretend that you graph them and this is the picture. Then the answer is where they cross. Okay. This point right here is the solution. Okay, it's the solution where they cross. And so the answer would be something like, I don't know, I'm guessing at that 1,4. Remember, it's a solution set. Okay, so let's say you solve the problem by graphing, which we'll do in a minute. Okay, you look to see where do they cross. And that's your solution. It's the point that's on both lines at the same time. Remember, a line is made up of a zillion little points. Okay? There's a zillion little red points. There's a zillion little green points. But there's only one place that's red and green at the same time, and that's where they cross. And that's our solution. And I guessed at this. Okay, in a few minutes, we'll do the problem where there's no guesswork. Okay, we'll actually do it. So that's the solution. This is one possibility. This is the most common one. The two lines cross each other. Now, there's another possibility. What if you graph the line? And here's equation number 1. I'll get out of the way in a second. So you graph equation number 1, and then you graph equation number 2. And the graphs look like that. Okay. Well, these would be parallel lines. Okay. Do parallel lines ever cross? No. But we're looking for where they cross. That's what we want. Where do they cross? But they don't cross. So this is an example of no solution. Okay. Again, graphing is going to be one of the methods we're going to use in a few minutes. If they cross, then the point where they cross is our answer. If they're parallel, then there is no solution because they don't cross. Okay. Third possibility, and it's the weirdest of all, and students really balk at this. Okay. Students really balk. Let's say equation number 1 looks like this. You graph it. And let's say, for some reason, equation number 2 is right on top of it. Okay, this is also equation number 2. Really bizarre. Equation number 1 was there, and equation number 2 turned out to be right on top of it. They ended up being the same line. Okay. Now, hold on, because the solution is just really ugly. Okay. The solution that you write looks like this. The set of ordered pairs. So you go set brace like that, X comma Y, put a bar there, and I'll explain what this means. Just right now, I'm going to use terrible teaching techniques. I'm going to say, shut up and do this. Okay. And then you pick one equation. Okay. 2x minus 3y equals 7. You just pick one of the equations. Okay, it won't matter which one because they're the same. Okay. And again, if we have time tonight, we'll get to these, but eventually we'll get to them tomorrow also. What this says is any ordered pair that makes this equation true makes the other equation true. That's what that says. Any ordered pair that makes this equation true makes the other equation true because they're the same line. Okay, I know that's weird. For now, just write it down. When we get around to doing some examples, I'll show you what that means. Okay, I'll get to that in a minute. But as you're doing your homework, okay, you want in the back of your mind to be thinking of the 3 possibilities when you graph them. Do they intersect at one point? Are they parallel, or do they end up being the same line? Because those are the only 3 possibilities that you're going to end up with in this class. Either they graph as the same as the crossing lines, and we have one answer, or they graph as parallel lines, and we have no answer, no solution, or they graph as the same line, and then we have this weird solution. Very weird. Okay. One more thing.
I'm sorry, I have a quick question.
Yeah, shoot.
What is the solution for that? The same line? Is the solution same line?
No, that's what you're thinking. Same line. The solution is, okay, let's pretend I have a pen that's not running out of ink. Pretend, I don't know. Pretend that you had a system that was 2x minus 3y equals 7, and y equals 2/3 x minus 7/3. Pretend that this was a problem on your homework. Okay, and you were told solve this system using the graphing method. Okay, now your question makes me get ahead of myself in terms of teaching. So you graph these two by all the techniques we've been talking about. You graph them. Hang on, my battery's going dead. Sorry. There it is. Okay. And you graph these two, and they happen after you graph them to be the same line. Just, you happen to do that. Then this is what you put as your answer. Okay. You could have put this as your answer also. Either one, you pick either one of these. So when they're the same line, you write this mess and you pick one of the 2 equations you have and put it right there. Did that answer your question or not?
Yes, thank you.
Okay, same line is what you're thinking. but that is your actual solution. Parallel is what you're thinking, but that is your actual answer. Okay? All right. Anybody else? I want to add one more thing to this before I start doing some serious problems here. There's some vocabulary that goes along with this. And there's a couple problems in the homework. It's good to know the vocabulary, but I'll be really honest with you. I didn't put it on the exam number 1. Might be on the chapter 5 quiz. I don't know. I don't think so. I have to check. But we have vocabulary. This problem is called consistent and independent. When they cross once and have a solution, we call this system, oh, that's a consistent, independent system. It means they cross once and there's an answer. Okay? This problem is called consistent and dependent. This is where they cross an infinite number of times because they're on top of each other because they're the same line. Okay? Now, the word consistent means there's an answer. In mathematics, we say, oh, it's consistent. That means there's an answer. Independent means there's one answer. Dependent means there's an infinite number of answers. And you have this weird way of doing it. But it's more than that. Think about if you're an independent person. Okay, I'm independent. Okay, and your friends go this way, but you're independent. You want to go that way. You do it. You're independent of everybody. You go your own way. So look at these two lines. One's going one way, one's going the other. They're independent of each other. They happen to cross, but other than that, they're independent. To be dependent means, hey, if you go, I'm going with you. I depend upon you. I'm going to do whatever you do. We're tied together. So this is consistent because it has an answer, but it's called dependent because they go together. They depend upon each other. Okay, whatever. And a problem that has no solution is called inconsistent. Okay, so consistent meant there's an answer. It might be a normal answer, it might be a weird answer, but there's an answer. Okay, inconsistent means there is no answer. All right, so that's it for vocabulary. I realize that's a lot to take in. I want to do a couple problems and then get the heck out of Dodge. So let's see what I have. Let me get better examples. Uh-oh. Bummer. Oh, come on. What happened to all my notes? I'm pissed off. Okay. There we go. that really scares me. Okay. So I want to solve this problem. Solve by graphing. Okay. X minus 2y equals 16 and y equals negative 4x plus 1. Okay, so I want to solve this system by graphing. So what you're going to do is you're going to go in your notes, however you want to do it, and you're going to graph this, okay, on an XY somewhere. Then you're going to do this one, y equals negative 4x plus 1. You're going to graph this one somewhere like that. You're going to graph them both on the same grid. Okay, and then you're going to hope and pray that you can figure out where that point is. Where do they intersect? So that's the game. I give you about 3 minutes to graph these. Okay, we'll pause while you graph these. Remember, we just got done talking about this. Personally, I would graph this first one with a table because it's in what's called standard form. And I would graph the second one with the slope and the y-intercept. Slope and the b value. Because it's in y equals mx plus b form. That's this one. Okay. But you can graph them any way you want. So we're going to pause. I'm going to pause the video. Okay. So I took the top equation and I took my own advice. X minus 2y equals 16. I plugged 0 for x, got negative 8 for y. I plugged 0 for y, got 16 for x. Okay, so we're going to fake it tonight. Okay, this is 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I'll get out of the way. And this is 16, 0 out here. Notice if this is 8, 0, negative 8, then I know that that's 8 and 8, so that's 16, and I'm roughly in the same ballpark. So this is 16, comma 0. And I just guessed, I just decided if that's 8 here, just guessing with my fingers, that's 8, then taking the same measurement, 8 and 8 more is 16, which is what I wanted there. So here's my first equation, okay, which I didn't draw very well, but that's my first equation. Looks something like that. Now I realize that the question was, what if we don't have scratch or graph paper? Number one, there's stuff online that you can download just to help you. Number two is when you do this on Mom, she will have a grid and it will be much more accurate. Okay. So anyways, that's the first graph. So whatever, your graph should have looked something like that. And I realize it's kind of weird. Second equation, we have this one right here, which is y equals negative 4x plus 1. Because it's in slope intercept, for example, I know my slope is negative 4 over 1, which is rise over run. Okay. And my y-intercept is the 0, comma 1. Again, when my equation was in one format, I used one technique, a table. When my equation is in a different format, I use a different technique. In this case, rise, run, and y-intercept. So I start at 0, 1, which is right about there. And I rise -4, 1, 2, 3, 4, and I run 1, 1. So this is my other equation. This is my second one. Okay. The answer is where they cross. Okay. Where do they cross? Anybody have a guess at where they cross? No, no guess at all.
-8 and 2.
Well, look at this. This is -8 here. And this line is going up. So it's a little bit more than -8. Okay. I'd say it's -7. Okay. But you're pretty close. Okay. So, and remember, this is X comes first. So this is 2, -7. But you were very, very close. I know exactly what you meant. And that's a pretty good guess.
How do you get that mathematically instead of doing the rise over run thing?
Well, okay, there's 2 answers for that. One is tomorrow night, and the second one is on the test, exam number 1, and on mom, I'm going to require that you graph these. So you're going to be expected to graph these on mom and then identify where they cross. Okay, and when I give you my exam number 1, which is an exam where you have to show me all your work, there's going to be one of these where you still have to graph them. So I'm going to be real big on your ability to graph these by whatever technique you use. Tomorrow night, I'll show you how to solve these without graphing them. But I want to make sure you have all of these abilities. You can do it by graphing. You can do it by what's called addition, and you can do it by substitution. And there's other methods. So I realize graphing is a pain in the rear, and I agree with you, but I'm going to force it on you. You must be able to graph at least one of these. So anyway, back here, this was 2, 7. Your solution is the solution set, funny braces, of 2, -7, the ordered pair. You need both because it's an ordered pair, X, Y, X, Y. So you must have the parentheses there. Okay, that's an example of solving by graphing. Okay, again, I can't stress enough. I don't care what methods you use to graph as long as you graph them. Okay. So if you like the table method for everything, then go ahead and use the table method for everything. If you like rise over run and slope and all that other kind of stuff on everything, then go ahead and do it. But I expect to see these graphs. I have to see them. Otherwise, you will get almost no credit for that answer. None. So I have to see your graph. That's part of what I mean when I say solve by graphing. All right, let's try one more.
Wait, how did you get the 2 from the 3 on the point there?
2 from the 3.
Yeah, at the very end where you went from the point is 3, -7, and then the answer at the bottom is 2, -7.
Oh, that's a 2. That's my comma. I'm sorry.
Oh, I'm sorry. Okay.
No, that's okay. I got whoa. Okay, what have you been smoking there? Or what was I smoking? That's another one. No, that was my comma. So that was 2, -7, and I just wrote it down here. 2, -7.
All right. Thank you.
Okay, sorry. My bad. Anybody else? Bottom line is you have to know how to graph. So let's try one more. Easy one, ugly one. easy one, ugly one. Oh, we'll go easy one. Okay. No, you'll bomb on that one. I don't want you to bomb on that one. Oh, well, we'll see what happens. Okay, we'll do that one. By the way, just before I get to the next one, how do I know that that's the correct answer? I mean, I guessed at it and I kind of guided you to it.
Plug it in.
Yeah, and remember, it's got to work in both of these. If X is 2 and Y is -7, it's got to work in both of these. So you'll always know if your answer is right or wrong by just plugging it in. Always. Okay. So last question for the night. I want this one solved by graphing also. Okay, 3x plus y equals -1. All right, up here. 3x plus y equals -1. And 2x plus y equals 0. Now this bottom equation is a little bit funky, it's a little bit weird. It might give you problems. So solve by graphing. Again, I don't care what method you use to graph them as long as you graph them. Okay, so we'll pause. Okay.
Not finished. No.
All right. Oh, wait a second. I will tell you that both of these were rather weird and awkward equations to graph. Okay, weren't impossible, but they were kind of weird. So if you struggled, it's totally understandable.
Are we only supposed to get two different pairs? Or like 4 pairs?
Well, that depends on how you graph it. You'll get 2 pairs for this one, 2 pairs for this one.
Right.
But you graph the lines and you're praying that they cross one place.
Oh, I only got 1 pair for each.
Well, you have to have 2 pairs to graph them. To be able to graph, you think of them as separate problems first. So let's take the first equation, which is 3x plus y equals -1. Okay, you do it totally separate from the other equation. You pick x is 0, plug it in. So you get 3 times 0 plus y equals -1. Solve it, you get y is -1. But you have to get another point. It was always at least 2 points. Okay. So you say, okay, well, what if y is 0? Then you get 3x plus 0 equals -1. That means 3x equals -1. If you divide both sides by 3, you get -1/3. That's what I was talking about when I was saying this problem is kind of wacko.
Yeah.
It's okay. I mean, you can still graph it. Okay, we'll talk about another one in a few minutes. But you come over here, and notice I haven't even worried about the other graph yet. You have to treat these for a second as 2 separate problems. How would you graph this one? This is what you would go through. This is what you would do. So when x is 0, y is -1. That's what that says. When x is 0, y is -1. When x is -1/3, where's -1/3? Well, right about there, y is 0. So this is -1/3, 0. So this is the graph of the first equation. This is equation number 1. And I haven't even looked at equation number 2 yet. This is the graph of that. Okay.
Okay,
now,
so I just got all the ordered pairs that I need now.
okay. Now plot them and draw the lines. So I'm going to go to the second equation now. There's my first equation. I'm going to go to the second equation, which is 2x plus y equals 0. That's my second equation. Now, do you want to use a table like we did here? Or do you want to use slope intercept? That's totally your choice. Okay. I'm going to say we're going to use a table, but this was a trick question. We're going to use a table. X, if X is 0, then we plug it in. 2 times 0 plus y equals 0. That means y equals 0. Okay, now wait a minute. Hang on. It takes 2 separate points to be able to graph a line. If we plug y equals 0, we still get this. This is 1 point. You need a whole nother point. Okay, so you have to pick some other value for x. Remember, we started graphing way back in chapter 4 by picking random x values. So this is the same, this 0, 0, okay, it means it goes through the origin, but it also means I have to pick another random point.
I just got the lines crossing somewhere, but I'm not sure like exact. Do we just guess what that point is?
Until you get to mom, yes, mom will be much more accurate. So I'm going to say, what if x is 1? Then I have 2 times 1 plus y equals 0. Remember, we could pick a random x, plug it in. So this is, if I take 2 away from both sides, I get y equals -2. So when x was 1, y was -2. So for my second equation, it's going to go through 0, 0, which is what that is. And it's going to go through 1, comma, -2. Okay, which is kind of like that. Well, it's kind of like that, actually. So my graph will look something like that. Okay, something like that.
Well, I got something way different.
You did?
Yeah, I got like perpendicular lines.
I got parallel.
Well, they're not parallel, but they're so close to being parallel
Sorta.
that it's hard to see. Wait a minute, where was the problem?
I don't know how they're perpendicular on my paper though. It makes sense when I plug it into the problem. You just make the the unknown. You just make the unknown any number that you need to satisfy the equation, right?
Yeah. So what did you get?
My ordered pairs are 0 and -1, 1 and -2, and 2 and -7, and 3.
Wait, time out. If x is 0, it can't be -1. If you plug
3
in
times 0 is 0.
Oh, wait a minute, you're back on this equation. I was already on the other equation.
Oh, yeah, I guess I'm way behind. Sorry.
Okay, but you're right. You could pick any points, but your graph should look like that black line. Then the question is, what does your other graph look like?
So with the second equation, did you find for both x? I thought we're supposed to find for x and then y.
I did, but it turned out that when x was 0, y was 0. So I had to plug other points in. I had to find other points.
Okay, so if I do it the other way, it's going to mess up the graph.
It's going to do what? Say again?
Is it going to mess up the graph?
No.
If I find for x, I mean y, if I find for x and then find for y?
No, it'll be fine. It should be fine.
Okay.
So what did you pick for y?
0.
But then that'll give you this. So these two are
Oh.
the same point.
Okay.
So you have to get a totally new point.
Okay.
Something totally new. So I just randomly picked one. Look,
Is there like a trick on how to organize these equations so that you don't confuse the two when you're working on them? Or
yeah, keep them separate like this.
well,
Build this
there's
table for equation 1, build this table for equation 2.
the little plug table thing.
Yeah.
I keep trying to copy yours and it's just not working out for me for some reason.
Okay, well, hang on a minute. All right, class, that's it. We're done for the night. We have a quiz tomorrow night. Stick around and I'll answer this. I'm gonna put this on pause or stop and see if I can